Um, Anybody know about Enterprise Service Bus? A couple of people, a bit. What feelings do come up? Is it positive, negative, or beautiful? See, thumbs down. Well, Listman is a bit about system integration, but it's definitely not an enterprise service bus. So my name is Doeke Zanstra. I'm programming since 1984, when my dad got a pocket computer. Besides Python, I also used to program in C#, in Java, Objective-C, and JavaScript. I worked at Ethos, KPN, ExxonMobil, and Archipunt, a local company. And I get energy when structure and creativity come together. Well, my talk is about Listman, and I first want to explain what started this. Well, I was working for a rapid growing company. We had multiple information systems in place, and it was pretty hectic. And problems arose like poor data quality. And here you see a system overview. I didn't name any systems because that's not really important, but you can get the gist of it. And when automating, it quickly becomes a spaghetti like this. It's the naive approach, quickly write something to get something fixed, but it's becoming unmanageable completely very fast. And that's why there is the bus architecture. Big companies use that's the enterprise service bus. Every communication between systems needs to go via the bus. And those are systems like BizTalk from Microsoft. But for a small company, at the time we were 40, growing to 120, it was clearly overkill. And for you that don't know the thing, the tagline is actually just a system like the others, only it's connecting the other systems. Before I started writing, I wanted to sell the idea internally because it was a pretty ambitious plan, and I need to have management on board for it. So I made an internal presentation with actual use cases, fixing real-world problems, so people could see what they were getting into. And they were enthusiastic and also curious, so that was a big plus. In this presentation, will show you some examples I made. And first, I start how I approach things. So let's get technical. I considered all data as tabular data because that makes things very easy. And my plan was to store all data as a copy in a database, have views made available so other systems could access the data, and use SQL schemas to organize systems like Google Worksheet is a system, and Microsoft 365 is a system. Right. And my tooling of choice was Debian Linux. I developed on Mac OS X, obviously. Postgres was the database, and I programmed on with Python, Flask, and SQL Alchemy. I tried to be pragmatic, made stuff generic when it makes sense and when it's easy. And don't be afraid to hardcode stuff, you can untangle it later. And also I had a focus on read-only use cases. For example, it's easy to think when you create a user, you want to have made accounts in all systems automatically, but it's very complex, and we are not creating an autonomous robot here. Yeah. So on the next slide, I show you the architecture I started with. No Python here. And I made it as simple as possible so I could iterate quickly, and complexity comes with time nonetheless. In the middle you see the system I started with, a database, and the bash script is scraping data from a system. I used curl for that to fetch a CSV file, and with CSV kit it got loaded into the database. CSV kit is actually written in Python, so I used a bit Python but didn't write it myself. So the customers were loaded into the database, and it was scheduled via systemd. And on the left you see the client, and for that at the start I used the Mac OS X client written in AppleScript. It could query the database for the customer data, so it could be used elsewhere. At this time I also spent some time at making it easy to generate a database. I did a couple of things. Are there any make users here of make files? I see lots of hands. I like that. I like make. It's all tool. It's still usable today. For I told you, every system gets its own schema. And I also gave it a target in a make file, so I could just say make space Microsoft, and then all the parts of the database for Microsoft was being created. And I also made a small bash script around a pSQL, which is used to access the database to create tables. I made some things like easy to create the environment-specific scripts. Like if you start a directory name with dev, the content of that directory only gets executed in the development environment. And also made it easy to use test data. So it was a lot of work for just one list, but from this solid basis I could iterate quickly. And the second example, I want to show you some real Python code. This is code actually from this was run on production. It is functionality. It's a web interface. Well, this is obviously not only code for a web interface, but with these 4 lines I can generate a difference between 2 tables. And you just, in the first 2 lines, you add a schema name, a view name, and a primary key name, a column of the table, so they can be compared if the identity is the same. And you can also specify some fields in a list, so you can textually compare fields. And then maybe it makes more sense in the screenshot I made. This is the HTML screen. 4 blocks. The first and second block show the rows presented in one but not in the other. And the third one shows textual differences in the other fields. And this proved to be the killer app, because with this screen some users could just check the data integrity between 2 systems, and there were quite a lot. So it helped people much. In the first iteration I made this, you could only compare one list, but later I made it configurable and more generic. So, and then we come to the third example. The subtitle is Python to the power, but clearly the previous screen was also written in Python, but until this point I loaded all the lists. I didn't count them, but it were more than 10. I loaded with bash scripts because it was easy, but it also proved some problems, because it was taking a lot of work. CSV kit generates a schema or a data definition language for every table. So I wanted to address some of those problems. So I taken two approaches. I made a generic CSV Excel adapter, and for other parts I made specialized REST interfaces. And the generic CSV and Excel adapter works via some JSON configuration. This actually starts in a database. Every list has its own JSON document with configuration. And the renew key tells it how to renew itself. With the attribute type, you can specify the type, obviously. File is just a generic name for anything with a file, for CSV files, for Excel, but you could also extend it in the future. And with the adapter, you can load it. And this is a CSV. And the encoding and delimiter attributes are just passed through the CSV reader, standard of Python. And field required fields, that's used to check if the correct CSV file is uploaded, because things might go pear-shaped when the wrong CSV with similar but not exact the same fields are uploaded. And finally, the last attribute is in this we had instructions from how to download the actual data. Again, the next screen shows how it's rendered in the web file, in a web application. And in this screen, people can quickly fetch the CSV file. They don't have to know how to do it. They do need to have access, of course. And when you do this once or twice a month, it's perfectly fine. It's writing a REST adapter is a lot of work, and this could be implemented quickly. And now I show you how to get the data into the database. As I told you, the CSV kit had data list specific tables. And for this, now I wanted to have just a generic table, so I could use one simple code. And for that, I thought up the JSON row type table with just two columns, an ID for the primary key and the data for the JSON document. And on the right, you see the configuration, how to get the data into the database. At first, I had a naive approach with truncate is true and without a unique constraint. And then, well, basically first the table is emptied with truncate, and then every row is inserted. But later on, I also added support for synchronization with update, insert, and delete. So only the change data gets updated. And even later I also thought up JSON row store, so per system I only need one table, and use the list name in the key name. And finally, in this group of examples, we have the REST strategies. The system-specific adapters, obviously. Some things also came up, like sometimes there's a lot of data from our registrations, and most of the times I could just say, well, I only need the last three months of data, so I only fetch that. Another way to address to have more up-to-date data is to distinguish between a full sync and a quick sync. A full sync is just what I just described. After the moment the data is similar, it's exactly the same. And with a quick sync, I only fetch changes from today. It depends on the system. Sometimes you have other options, but most of the time you just can say, I want to have the changes of today. And then you can schedule the quick sync every hour or every 5 minutes. Most of the times it only says which records were inserted or updated, and deletes weren't returned. So the downside of this option is the deletes will only be visible the next day within Lisbon. And then I came to a point I want to show data in the tool itself. Just show the data as a HTML table. Can be very very helpful, and it's also it's declarative, and it can help people a lot. Like this one, this shows double lines in some kind of list, and for this I only needed to write a query and add this this declaration. And more interesting is this one, where I can add in the web application you see HTML table with a finally added column with a link to Jamf that will open the computer from the list in the target system. Here I use the example.com URL. And finally, the most complex was this one. This also adds a download option for the list. And the use case for this one was we have like a multifunctional copier, and it also supports scan to email, but it's really cumbersome to enter email address into the console of the device. And with this declaration, I had a query of changing the Google accounts to a format the multi-copier of the multifunctional supports. And then I added directions how to create the CSV file. And in the description there are instructions for the user how to upload the CSV file into the copier again. And we use that quite a lot because we had a lot of employee going and coming. Another way of publishing data is externally on the intranet. We use Jekyll at our intranet. Jekyll is a static site generator, and it also supports data files like CSV. So I could export data to Jekyll and upload it with secure copy. And then, for example, it's easy to make a mugbook. For this I combined the Google accounts, and I had a custom Excel from for some additional data, like the function title, amongst others. And with some JavaScript, I had a really nice and handleable address book for people. We have telephone numbers. And here you only see the filtered version of our team. Oh. Another one is the holiday planning. Everybody maybe knows Excel with the green dots when people are not working. This one is generated from data. It's a combination of holiday registrations which were approved and a roster, and also other leaves like parental leave. And it's privacy preserving because the view doesn't tell what kind of day off people have. So it was very useful. And I had even another way of exporting data and adding data to it. One was for my own use. Here we see a list of Jamf computers. As key has a serial number, and it was easy to add some annotations, annotation column to it. So if I had a computer with a bad battery or failed Wi-Fi, I wiped it and I marked it in the comment field. And then sometimes when the computer handed over to a new personnel member and he had the same problem, I knew it was hardware bound and not a software problem. And the other way I could do this, I could also update Google Sheets or Excels. For example, people want to add data to their own lists, like you have, again, accounts from Google, you have name and email address, and people want to add data of themselves, like if somebody is participating in a social. I only had this in code, but this is basically it. It can update a spreadsheet by providing a spreadsheet ID and a sheet name. Then I also use the pointer now. Here you can, there you can index the table, so it knows it's a kind of a database, and with my identity function, it can determine the identity of the row, so it's basically returning the email row most of the time. And with the mapper dictionary, actually the columns can get updated. The column names are in the first row as a convention. And the argument or the lambda here is like the function. The d is the row of data fetched in the first line on top, and then it returns what needs to be filled into the spreadsheet cell. And with sync you can actually apply the things. This could be also declarative, but there was really no need for it at that time. Well, there was a conclusion. So basically everything in the service bus is list. Lots of use cases were tackled, and I had really fun doing it. Thank you.